Hello, everyone. I hope you're hearing me okay. I hope everybody's okay. And we have an exciting day today. Okay. Let me know if you can't hear me, okay, or see me. I've had problems in the past, and I wasn't able to schedule this this transmission. So I hope everything is, from a technical standpoint, is running okay. Anyways, we have some fan mail, okay, and I'll get to that real quick. We got a long day, okay, and again, remember I'm putting the timestamps, okay. So after it's rendered, okay, the video is rendered. So I'm going to be putting the timestamps so you can jump to whatever subject you think is more appropriate for you. Okay. Okay. The first comment has to do with virus. Says a virus has no location because it is not a virus, but it is an egg of a microparasitic worm. And this fellow goes on to explain how cancer works, and he says it's a microparasite or its egg uh, in the blood of stinging insects. Okay, so that's his take on that. He goes through that. You can read that. I have a different take on that. This is my version. Okay, I think it's got to do with genetics. Okay, and so I don't know. Everybody reaches their own conclusion. I'm not a doctor. I don't do medicine, but this is my take on it. I get this from the Wikipedia, and I subscribe wholly with it or to it. The six hallmarks of cancer. These characteristics are required to produce a malignant tumor. Cell growth and division absent, the proper signals. Continuous growth and division, even given contrary signals. Avoidance of programmed cell death, limitless number of cell divisions, promoting blood vessel construction, and invasion of tissue and formation of metastasis. Um, I found a comment there which I agree with. Cancer occurs after cells are genetically altered to proliferate rapidly and indefinitely. And that essentially is my take on this. I think it's a genetic disorder. Some people get Alzheimer's. Other people get cancer, diabetes. What do I get? I get arthritis, and I think these are ailments, diseases, whatever you want to call them, of old age. Okay, and and I think they're genetically related. At some point, the genetics kicks in. You don't reproduce your DNA as well as you should, and whatever you reproduce is, you have a certain tendency to certain diseases, and that's the way I see it. So I don't think it's a bug that causes cancer. That's my 5 cents worth on that. Okay, I hope everybody's hearing me okay. I don't see any comments. I don't know if everybody can't write, or maybe they're limited the uh, by the system. Okay, anyways, if oh, okay, thank you for that note. Very important because I don't even know. Many times I was caught just speaking to the wind. Okay, thank you guys, appreciate it. Okay, let's continue here with the next comment, and yeah, okay. Here's the next comment. The rope hypothesis is a troll theory. It is meant as a parody of string theory. Okay. There's another comment along the same line, so I'll treat them both together. This fellow says, if I can get it up, why do you talk about these guys? Talking about, people like Al-Khalili, okay? Says, what about the greatest scientists of our time? Why don't you talk about Witten and Weinberg and Maldacena? Well, aside from Weinberg, who is a quantum guy, Witten and Maldacena, they are string theorists. And so let me attack that. Let me deal with that for a second because I've had this issue come up time and again, okay? And here I'm going to state this so that people are aware, okay? And that's that, first of all, these guys are not scientists. They're mathematicians, okay? Their explanations are all irrational. Their explanations of mechanisms are all irrational. So you can't include them as physicists or as scientists. A mathematician is not a scientist. He can only describe sciences about explaining mechanisms. We need to figure out how Mother Nature runs her universe. That's what we're interested in. That's what science is all about. Once we figure that out, we're done with science. That's what science is about. Science is rational explanation. String theory explanations are all irrational. There's no such thing as a 1D line, which is what you see there, curved around and moving. Okay, supposedly that's gravity, as you can see it there. How that produces gravity, we don't have the slightest clue. Okay, and it's irrational to say that a line vibrates. There is no physical object called line. There is no physical object that is 1D. Okay. Now there's a 2D line. That's the one we can draw, and that is an object, but it's an object that does not exist. It's not only it's not 3D, but it doesn't have location. And so string theory is based on this. It's a mathematical theory only. It's based on this 1D string that vibrates and supposedly makes up the particles of quantum mechanics. The issue there is that all these people are no longer interested in explaining how this universe works because they consider that philosophy. They dismiss that as philosophy. Okay, so all they're interested in describing mathematically, and that's what string theory is. The fact that they use the word string and I use the word rope or thread has nothing in common, one thing with the other. The so-called string is not a string, okay? Let's make sure we understand it. It's a 1D line. It has to do with mathematics, and what do we find in mathematics? That the word line has not been defined. No one can define it. They tell you they can't define it, right? Because a line is an object. It belongs to geometry. It better be a figure, and there's no such thing as a 1D figure. Maybe a 2D figure, maybe that's what a line is, an elongated rectangle, that we can deal with. But a 1D line, no. What they're talking about is itineraries, rectilinear itineraries. That's what a line is for the purposes of mathematical physics. And word physics doesn't belong in there together with mathematical. It's an oxymoron to put those two words together. Okay, another comment here. And this fellow says, gluons are vector gauge bosons that mediate strong interactions of quarks in quantum microdynamics. We went over that the other day. Okay, he just runs through what a gluon is. And they have all these definitions. He probably pulled this out of the Wikipedia or one of those sources. What's the issue? There's only one issue regarding gluons, okay? And you can take this to the bank. You can take this to any person out there who vouches for quantum mechanics, and you'll trash them. You'll easily trash them. Why? Because this is the issue. This is what a gluon is. A gluon is a bed spring that keeps three quarks together. In this case, the two ups and one down represent the proton. The neutron would be the other way around, okay? One up and two downs. But essentially, they illustrate it as a bed spring, okay? And you say, well, what's the problem with this? Well, the problem is the force of pull. See, they had to cheat, and they can't do it with particles, so they do it with these bed springs. Now, where in the standard model, here it is, okay? Where in the standard model do you find bed springs? In fact, you find no shapes whatsoever, no pictures of any of the particles. The gluon is that one over on the upper right, right between the Higgs and the top quark, okay? And so what is the gluon? Gluon is supposedly a particle, okay? It's called elementary particles. Particles. What's a particle? Well, supposedly it's some kind of discrete little entity hopefully 3D. Maybe it's cubic, maybe it's roundish, spherical. That's what everybody imagines it as. That's what everybody typically illustrates it when they're producing the movement of these things. But here, these people are illustrating it as a bed spring. That's a gluon. And so the question is, how did they end up with a bed spring? Okay, so that's cheating because that's the big issue with quantum mechanics, also with all of mathematical physics for that matter. And this is the issue. And again, you can take this and fight and destroy any argument in quantum mechanics. Please produce the force of pull. How does a quark pull on another quark? How does a proton prevent another proton from flying away? They're both positive, right? They should explode. The nucleus should explode, especially uranium, 92 protons. Man, all those positive charges, they should want to repel like you wouldn't believe. And so how did Al-Khalili explain it the other day? And he's not the only one. You'll see this in a couple of videos out there. And they'll explain it with the, what is it? The, this material, Velcro. The Velcro. They put two Velcros together. But as I showed the other day, Velcro has these hooks. So again, hook, we can all understand a hook pulling on another hook. If that's what the gluon is, two hooks, one pulling on each other, fine, why don't they illustrate it like that? Why don't they illustrate it as hooks if that's what they're going to use the analogy for? I mean, they put the bed spring, they can also put the hook, right? But then they have a problem because the question is, how does the gluon get attached to the proton? I mean, is there another hook and it just stabs the proton in the middle of its guts and just hangs on there, and then the other hook hangs onto another gluon? I mean, how do they do this? What's the mechanism? What's the physical mechanism? And of course, they cannot illustrate it for you, and that's the big problem. The problem is the force of pull. And that's why they say, well, we don't understand quantum mechanics. Of course you don't. And you never will, because you can't produce the force of pull with particles, with discrete particles. That's the whole issue. Likewise, you can't explain why the electron doesn't spontaneously leave the atom. Why? What keeps it bound to the nucleus, to the proton to begin with? Why doesn't it spontaneously just fly away? What keeps it faithful to the proton or to the nucleus? And they can't answer that question because what are they going to put in between? Well, Rutherford, he put nothing in between the electron and the proton. He said there's nothing there. Then they turn, people like Dirac, and he's created this sea of particles that annihilate and go back to being particles of space, I guess, right? So that nothingness is full of junk. What is it? What is this junk? Particles. So this famous atom that is completely empty space, or 99% empty space, well, that empty space is not empty. That's what they tell you next. It's full of stuff. So if it's full of stuff, we haven't answered the question. If it's full of stuff, we still haven't answered the Rutherford issue. The fact that, he said that 99% or most of the atom is mostly empty space. That's one issue. The other issue is that they still cannot explain the force of pull, why the electron remains faithful to the proton. Okay, so these are the issues that these people need to answer. And you'll never find an answer to that. You should ask these questions in Quora. Some of these hot shots, send them a question. How does a proton pull on an electron? Very simple. I mean, give me the mechanism. I want to know. I mean, are these discrete particles? Well, according to the standard model, we put this up here again. Okay, all of these are discrete particles. So a proton is three of these quarks together. Okay. And an electron, you'll see it there, okay? Where is it? Electron, third one down from the left column. So if the electron is a bead and the proton is a bead made of three beads called quarks, fine. What keeps the electron bound to that proton? That's all you got to explain. And you can't say positive or negative because that's a mathematical gibberish. It doesn't tell me anything about the mechanism. We need to find the mechanism. And right, the only answer they could come up with was that nobody can even imagine the atom. So after you take 10 years at the university, you finally reach that, the Wizard of Oz, and he tells you, look, don't even try to imagine it because we can't. That's the answer. Okay. Okay, another issue here raised by one fellow. He says, if all objects are made of electromagnetic thread, which is 3D, then circle is also object. How does it become 2D? Okay, or how does the object become 2D? Object is that which is bounded by surface, according to Aristotle. Yeah, we have no problem with this definition. I do. Okay, now Bill said that we have a problem with this definition. Exactly, because surface is not perfect criteria to define object, and also according to him, objects may be 3D as well as 2D. I'm completely confused. Okay, let's see if we can unconfuse you. Okay, we try to unconfuse people here. Okay. And so here is the reply to that. All objects that exist are made of threads. Okay. So we're not saying that all objects are made of threads. Okay. We're saying all objects that exist. Okay. What does that mean? It means that you have to have location, like it says right there at the bottom. Exist equal object plus location. So exist is not equal to object. Okay. And circle is not an object that exists. Okay. Circle is an object, but it does not exist. And what you're confusing here is existence, what is made of threads, with non-existence. We're talking about two separate issues. An object has nothing to do with the issue of existence. Not all objects exist, okay? Surface is a 3D concept, and object is equal to 3D. This notion is the definition of ordinary speech. Why is it? Because 3D relates to what we can see and touch. That's the notion people have in the back of their minds when they talk about 3D. They think of something that's out there that you can see and touch, and that's the notion people have of what an object is. That's the notion of ordinary speech. In science, an object is that which has shape, not that which is 3D or that we can touch or that we can see. And it exists requires one additional criteria or attribute, which is location. Okay. Now, so a lot of people make this error, and here we have two famous guys. I mentioned them before. David Hume and Immanuel Kant, whatever. And these people had problems with this as well. They couldn't figure out the difference between object and exist. And Hume said the idea of existence then is the very same with the idea of what we conceive to be existent. To reflect on anything simply and to reflect on it as existent are nothing different from each other. That idea, when conjoined with the idea of any object, makes no addition to it. In other words, he thought that existence and object were synonyms because he was thinking of the definition or notion of ordinary speech, that an object is whatever's out there that you can see or touch. And so he said, well, existence is the same thing. It's what you can see or touch. Well, neither of those definitions are correct. An object is that which has shape, and existence is an object that has location. Now we can use these terms consistently, scientifically. And Kant had the same problem. Nothing is really added to it if I add that the thing exists. Yes, it is. To say that the thing exists means it's got location. So there is a difference between object and exist. But these fellows couldn't figure it out, and that's why we ended up today with these notions that people have, vague notions that they just take as a matter of fact, casually. They say, yeah, an object is that what's out there. A table is an object. No. A circle is also an object. Superman is an object. Anything that has shape is an object. Do they all exist? Do they all have location? No. Circle does not have location. So the issue is confusing first ordinary speech with scientific language. That's the first one, because no one's ever defined these terms. And the other one is that, exist requires that the object also have location, which not all objects have, because 2D objects don't have location. Okay, so Those are the issues. And unless you understand that, well, you're still in kindergarten. Kindergarten physics, okay? Physics, first thing you learn the first day is what an object is and what existence means. Because physics is what? The science of existence. Physics only tries to elucidate, tries to figure out what exists out there and how it works, the mechanisms. Okay, another comment. Okay, here, moving on. Can the ropes knot together? The intertwined ropes create objects. No, not exactly. Okay, so let's get that cleared up. Okay, I can get this thing in there. Here's the answer. Okay, twined threads form a rope. Okay, you see that at the bottom. Okay, ropes are always under tension. The rope. Okay, remember the rope is under tension. Okay, and the rope is not the same thing as the thread. The thread is one of these two guys, one red, one blue. Those are the threads. Okay, the rope is always under tension, not so the thread. The thread may come loose, okay, and swing around and create what we call magnetism. That's a long story. Unless you're aware of what the theory says, I'll have to leave that for another day. Little c, the velocity of light, is a measure of that tension. Okay, that tension that is across every rope in the universe that binds any two atoms, that amount of tension, that's unique to our universe, assuming there's another universe, parallel universe out there that is not connected to us. I don't think there is, but there could be. I mean, that's for people who want to speculate in front of a couple beers. You can speculate that there's another universe out there that is not connected to ours. It has a different amount of matter. Therefore, the velocity of light in that universe could be different because it's got more matter or less matter. Okay. If there is only one universe, in other words, all the atoms forming the matter inside what we call the universe, in other words, which cannot escape space, okay? All those atoms are interconnected. And if they're interconnected, the speed of light has to be the same from atom to atom, everywhere. No matter if the atom belongs to a denser medium, okay? So the speed of light is constant even through denser media, in the vacuum, etc., etc., etc. The speed of light is always the same speed. It never goes higher, never goes slower, because it's dictated by the tension on the rope everywhere throughout the universe. Now, this is moving. The whole universe is, remember, the universe is, all these atoms are moving, the planets are moving, the stars are moving, the galaxies are moving. So there could be a pull and release, pull and release, pull and release here and there across the universe. The impact that would have on the speed of light, on the tension of the rope, would be so minimal you would have to calculate it with a gazillion decimal points. So there could be, maybe it's not a complete constant in that sense, that if this whole thing is moving, there could be some slack here and there, somewhere in the universe, okay, some in the matter of the universe. But with all the matter in the universe, that's got to be, a gazillion decimal points. So for all practical purposes, the speed of light would nevertheless be constant across the universe, okay? And it's the threads that twine and form the objects, not the rope, okay? So it's not ropes. Do not confuse the rope with the thread. Lots of people do that, and I usually beat them up with my dough roller. Okay, let's continue here. Another comment says, what causes motion? Okay, what causes motion? Let's see what causes motion, see if we can get this answered. And here's the answer. Okay, first of all, we go step by step. Objects, for example, atoms are not created. You can't create an atom from empty space. You can't morph vacuum into a 3D shape known as an atom. Okay, that's the first thing. And atoms build everything out there in the universe that exists, okay? Not the atom you have in your head that you're visualizing. I mean the real atom, the one that has location, okay? The atoms that have location with respect to all other atoms in the universe, You cannot create those. You cannot transform empty space, truly empty space, vacuum, nothing, into an atom. It cannot acquire length, width, and height and spontaneously morph into an atom, and vice versa. You cannot take an object such as an atom and convert it into empty space. Okay, that means no atom can escape space because it has no boundary, and second, it cannot convert to space, or vice versa. So likewise, motion cannot be started. Here you have our universe at the bottom. This is one vision of it. Okay, you can imagine all that matter. That's our entire universe there. If you had God's eyes and you're outside the universe somehow or far away from it, which you couldn't do that unless every atom there is connected to your eye, but that's a separate issue. Let's assume that's what you imagine the universe to be. Some kind of ball, it's rotating. You have all these gazillions of atoms connected to each other. Okay, and what's around that black stuff, that's all space. It's not only around, but it's within. Why? Because most of what's out there, most of the volume is empty space. That means that atoms are a small portion of the volume of the universe. Okay, the word universe, meaning empty space and matter. Matter being all the atoms in existence. Okay, so because matter cannot convert into space, or leave that which has no boundaries, then matter has always been there. Okay? And if it's always been there, it's always been in motion. You cannot imagine a frozen universe, right, where someone gives a kickoff to that universe and begins to set it in motion, because then you have the same situation that comes with the issue of God. How did he acquire motion? Motion with respect to what? In other words, imagine God out there, right? And we're going to imagine him as a magician, as a human, right? Human-like form. He's all alone in the universe, meaning he's within empty space, right? Space had to be there to give him shape if God wants to be an object. So space had to be there. God could not have created space, partly because you cannot create nothing. I mean, I create nothing every day. I'm a magician. I create nothing. Okay, so it's easy to create nothing. The tough part is creating something. So here's God out there in space, right? We'll say in space. That means he can't leave space no matter how powerful he is, because not even the all-powerful God can leave that which has no borders, okay? Cannot escape space. And now he's going to create an object. He's going to create all this matter. He's going to create what we call matter, all the atoms in the universe, right? But the question is, how does he move? I mean, we can imagine his hand moving with respect to his leg. Well, how did he acquire motion? How did God acquire motion for the first time? Who set him in motion? So it's not only an issue of who created God, it's also who set God in motion. So you got to answer these questions. If you cannot imagine that, well, your theory dies there. Until you can figure that out, you have no theory, because you have no mechanism. And if you say, well, I cannot imagine, well, you don't have a theory. Sorry, that's it. And I do have a theory. I'm saying, there was no origin to matter and there was no origin to motion. We're done. Motion is eternal. Matter is eternal. Period. Okay? I hope that's clear. Okay, another comment here. This fellow talks about Ken Wheeler, says Ken's words are actually quite purposely chosen. Ken Wheeler is this bald-headed guy. He has several aliases, Theoria Apophasis, some others, okay? And he does YouTube. He's a YouTuber. He spreads nonsense, absolute nonsense, poppycock. None of what he proposes survives. He wrote a book. None of it survives either. So don't even read it. I mean, if you want to go nuts, go read it. I couldn't get past, I didn't get past half of it. I think I read only about 1/3, maybe a quarter, I don't know. And I gave up. You can't understand it. He just doesn't know how to write. And so there's no way you can understand his book. But then he's got the issue that he didn't define any of his concepts. And I say concepts, not objects. He doesn't have a single object in his whole book. It's all concepts. He uses the word field. He uses the word ether. Okay, and then he branches off into these other concepts which he assumes you know about. He's not defining them. He says, this fellow says, when you look them up in a dictionary, well, I shouldn't have to look them up in a dictionary. I have to look them up in his book because he's got to define these words in his book so that we can follow his train of thought. And of course, he doesn't define them, so there's confirmation of that, okay? They make sense only if you look them up. Well, no, we don't look them up. And second, they're all concepts. And what Wheeler does, he begins moving concepts around. He's moving ghosts and goblins around, okay? He's trying to avoid confusion and semantics. He does the opposite. He engages in confusion and semantics because he doesn't define his terms and because he's moving concepts around. That's the issue. It's the other way around. He is confusing. He does semantics, okay? He's trying to tell you that the concepts that he's moving around you're supposed to take them as objects. No way. None of them have shape, and we'll see that in a second. Hence, counter space is rest. Well, is rest a physical object? Because good old Wheeler is going to move counter space around. Okay, and we're going to show that in a second. Or the opposite of reality. Rest is the opposite of reality. What the hell? Not just the opposite of matter, but the opposite of all that is, whatever that means. Emptiness included. So, some people don't have the mental ability to keep up. And, it's not even worth analyzing this. Here's good old Wheeler. This is what he posted in his own site. Okay, so this comes from his site. Okay, and he says, there are centrifugal at the edge of every magnet. What's a centrifugal? What's a centripetal? Centripetal what? What's going out? What's going in? So he draws them. Are they arrows? Is that what it is? What is he talking about? He doesn't tell you ever. He just shows it. Then he talks about the counterspatial. What is a counterspatial? Please draw it. And then the radial. What is all this nonsense? And then he says, like the flywheel of a gyroscope. No, a flywheel is a physical object. That wheel there is a physical object. That's not what centrifugal, centripetal, inertial, and what is it? And counter space are. None of those are physical objects like a flywheel. So this is the issue. He's doing the same thing that the quantum guys do, that the mathematicians do. He's trying to sell you concepts for objects. And he says, look, here goes a centrifugal. Centrifugal what? What left ground zero? That's what I want to know. Please draw it for me. Don't explain it. Don't define it. If it's an object, you got to point to it. You got to draw it. So you got to start by knowing what an object is. And an object is that which has shape. So if he's got to talk about centrifugal something, that something moves centrifugally or centripetally or whatever, or inertially or counterspatially, whatever, it doesn't matter. If that's the movement, if that's what the object does, please draw the object first. I need to see the object. I need to see what's moving. And, one of the reasons Kenny stopped following me is I beat him up on the word field. I beat him up so badly. He said, what do you mean field doesn't exist? I had this problem with so many people out there because they all believe that field, plasma, and electricity are physical objects. That's the issue. And no, they're not. They're concepts. They're dynamic concepts in the sense that they're things that are moving are already concepts. Like a kangaroo that's jumping, that's a concept. That's not a thing. Kangaroo is a thing, but once the kangaroo is jumping, once the eagle is flying, once the shark is diving or swimming, it's no longer an object. Now it's turned into a concept. Okay, Superman flying is not an object. Superman is the object, not Superman flying. One is a movie, the other one is a photograph. And people like Wheeler have never understood that because it destroys their religion. And the word field was, at the heart of it. Okay, another comment here. Moving on. Okay, fellow says, the so-called critical mass at which a star is supposed to collapse into a black hole ghost might actually be the point at which the gravity between a critical number of atoms is sufficient to start merging them and start fusion reaction. Okay, in other words, it might lead to the formation of a star instead of a black hole. Okay, that's how the star is born to begin with. The more hydrogen available, more fusion reactions, the brighter the star. And at some point, if the hydrogen keeps aggregating, the pull is sufficient to fuse nuclei beyond iron. the supernova, okay, with a consequential release of quite a lot of thread as radiation and light. Okay, I just want to comment on what this fellow wrote, and that's on how stars form. Okay, not so much how, well, yeah, stars form. This is first the reigning theory, the nebular theory. Okay, it looks more or less like this. Okay, you see that there's a cloud of gases. They swirl around, they eventually condense, and they turn into this star known as the sun, and the little planets flying around. Okay, so that's the reigning theory. Okay, it doesn't take much more than that to understand it. Okay, what is the problem with this? Okay, there's a couple problems with it, and I'm just going to mention the two most salient problems. Okay, here's the first one. Okay, and here's Ceres. It's the largest asteroid, and you can see it's quite roundish. Okay, it's only 950 kilometers, which is not much, and it's almost perfectly round. Okay, or quite round. And then you have Mimas, which is one of the moons of Saturn, and it's the smallest spherical object in the solar system. It's only 400 kilometers across in diameter. Okay, and the question is, why are these two celestial objects so spherical? What made them so perfectly rounded? Why do they look like bowling balls? Okay, and you might say, well, it was gravity. But the question is, do they have enough gravity to be able to form such a perfect round sphere? And, a lot of people have their doubts, okay, and they might speculate that, yeah, that could happen. They don't know enough to answer that question. But then there's a second issue, and it's this one here, and you have Ganymede and Callisto, two of the moons of Jupiter, and you can see that they're differentiated. Differentiated means that as you go deeper into the object, okay, you find heavier and heavier elements. So in the case of Ganymede, you have like iron in the core, more or less like the Earth, and as you work your way up, you get to these lighter elements on the periodic table. Okay, Callisto is not as well differentiated, it's only partially differentiated. So what's the problem here? How do you create that pattern? The roundness and the differentiation. Those are the two issues, okay? Those are the only two I'm going to analyze. And here's one way, and it also destroys the Flat Earth Society, okay? I can get this thing up there. That's how you produce roundness of a planet, of an object such as the Earth, gigantic objects such as the Earth, okay? It's round because everything pulls, that's the word, pulls towards the center, okay? So the guy on the other side of the planet, okay, is being pulled in your direction, 180 degrees in your direction. And there's no way to avoid this if every atom is connected to every other atom. That's why objects are round. Here's another vision of that. It shows you air, okay? And you can see that every atom of oxygen that forms the air, or whatever you got there, nitrogen, any other trace elements, it doesn't matter. Every atom that forms our atmosphere is pulled towards the center of the Earth, and is even pulled towards the other side of the planet by atoms that form the air on the other side of the planet. So everything pulls towards the center of the planet. That explains roundness, okay? Now let's explain not only roundness, but in addition, let's explain differentiation, which is an important point here, okay? And for this, we got to go to a gentleman, a Russian fellow, and his name was Oparin, okay? In 1924, he wrote a book, The Origin of Life on the Earth, and he also wrote a paper saying The Origin of Life, which everybody should read. It's online. And here's a most important statement. He said, there was a time when the Earth too was passing through the same stage of development as the Sun, namely that of being a yellow star. Later, as it gradually radiated its heat outwards into the cold interplanetary space, it became cooler and cooler. It turned from a yellow star into a red one. Its light became dimmer and dimmer, and finally went out altogether. The Earth became a dark planet. also known today as a black a black dwarf. Okay, so what this fellow is saying that the Earth used to be a sun and a star, and I totally agree with him because now we can explain these two things. And here you can see a schematic vision of that. If a red supergiant condenses eventually, not only to a round perfect sphere because of enormous gravitational tugs towards its center, it also explains why the heavier elements end up in the center of a star, and as you go outwards, you go all the way to the lighter elements, even to the gases, which is what is on the surface of a star. And if you look at a planet, it has the same structure. Okay, not only is it roundish, but it's differentiated in the same way with the heavier elements on the inside and the lighter ones on the outside. What do we have on the outside here on Earth? Well, we have a gas. Okay, and you also find water. What is water? Well, water is not quite between, somewhere between gas and solid. Okay, so as you move out, you find lighter elements, eventually gases. That's the structure of a star. So my point is that I think Mr. Oparin was correct. I think I like his theory, and I don't claim it to be mine. I just think that his theory, the fact that the Earth used to be a star, explains a lot of things for me. Especially, I mean, if you take Callisto or Ganymede, think of this, and you'll see that the nebular hypothesis cannot answer that question. Here you have Jupiter. Jupiter is a star. It's a star that was not big enough to fail. Okay, it's what is it? A bunch of gases. That's what Jupiter is. Helium and hydrogen floating around, and maybe some other gases. The question is, Jupiter's a ball of gas, and here you have these moons that condensed at the same distance from the sun. Okay, and if it condensed at the same distance of the sun, how come they became rocky moons? Why did they condense and end up with being small gas balls like Jupiter? And if you go to Saturn, to Neptune, to Uranus and Neptune, you find the same thing. The moons that surround them are pretty much solid. You have a couple exceptions, but in general, you cannot explain the rocky moons. And the question is, how did that happen? If the nebular hypothesis for the creation of planets is correct, then we shouldn't have rocky moons orbiting Jupiter, Saturn, etc. So that's one issue. The other issue is that if you want to explain roundness and differentiation, all you need is turn each one of these little moons and asteroids and what have you out there, turn them into stars. That's what they were. They were stars that condensed into this round differentiated object. And of course, that took trillions and trillions of years, which is what it takes to make a black dwarf like the Earth or even like our moon. It takes trillions of years. And of course, that destroys Big Bang Theory, which is only 14 billion years old, the universe, right? So they say there are no black dwarfs around because there's not enough time to have created one. Well, we see them all around in the solar system, and that destroys not only Big Bang, but it explains differentiation and roundness of those objects. So think about that. That's my take on that. Okay, let's get on with Mr. Al-Khalili. We left Mr. Khalili the other day. And again, I'm going to put timestamps on all these, okay? So be aware of that, those of you who tuned in late. Here's the summary from last time around. Mr. Al-Khalili essentially said that, they were able to answer all questions with the atoms. Once they figured out the atom, that the atoms actually exist, which is what Democritus said 2,000 plus years ago. Once they proved mathematically or otherwise through experiments or whatever, through deduction, that atoms exist, they were able to answer every question. That's how he starts that's how he boasts, starts his his presentation. He says protons are held together by Velcro-like particles, even though there are no Velcro-like particles in the standard model. Okay, sun shines because protons are squeezed together. And what do you mean squeezed? I thought they were being pulled by the Velcro. And see, now they changed the language. They say they're squeezed and squashed from the outside. That's the notion he gives you. So he changes the language and fools you. You shouldn't you shouldn't lose track of the fact that they cannot explain pull. So you should take them back and say, hold it, you just said Velcro. Velcro pulls, two hooks. Please illustrate for me and how that works, that mechanism. I want to see that, and then show that to me on the standard model chart. And of course he can't do that. It's against his religion. Okay, sun can't produce all that helium. He said that's what Gamow suggested, that he couldn't, and it had to be produced at the Big Bang. And later on, they were able to prove the background radiation, the existence of the background radiation, 3 degrees Kelvin there, that was flooding the radars. Okay, and they couldn't get rid of that, Penzias and Wilson, and so they got a Nobel for that, for not being able to get rid of noise. They said, oh, we proved the background radiation, whatever that is. I mean, again, they can't see it. They said we heard it, and it must be there. And where does that come from? Well, that came from the Big Bang 14 billion years ago. And again, it's all this nonsense that they have because it's all done with particles. And of course, with particles, they can't explain anything rationally. And then at the end of the story, they say, well, we don't understand it anyways, but we proved it with experiments and with technology and with math. That's it. That's the answer you get. Okay, so where does he move from there? Well, he justifies how Rutherford, good old Ruthy here, and what he did was he was able to show, right, that an atom is mostly empty space. Okay, so he says, concluded that an atom is mostly empty space. The question then became, how could this empty atom possibly make the solid world around us? Yeah, good question. You're saying that all the building that you constructed is, all those atoms are mostly empty space? So we have a building constructed out of toothpicks? Is that what these people are saying? Man, don't scare me. Don't tell me that, the Empire State Building, I've been up there, it was made out of toothpicks and almost all completely empty space. Jesus, you should have told me that before I went up there. Okay, so where does he move from there? Well, Rutherford proved that using his gold foil experiment. In other words, he shot some atoms. Okay, he shot them at gold foil, and he was surprised because he thought that all the atoms that made the gold foil surface, that everything would be bouncing back. And actually, all the atoms went through except for 1 out of 8,000. And the one that bounced back, he concluded, hit the center of the atom, which was the proton, the positive proton. That's why it bounced back. That was his conclusion. Of course, he was blind. He wasn't seeing any of this. That's just a conclusion based on what he saw. And again, I don't think Rutherford was a very smart guy. They have him as this hero, like they have all these guys as heroes. And he reached the wrong conclusion because he had the wrong hypothesis. The wrong hypothesis is that everything is mediated by particles. And of course, if you're going to use the particle as your bread and butter, as your building block, then you're going to run into trouble when you try to make sense of it. And that's why they always conclude, well, we don't understand it. Well, if you don't understand it, it means that your conclusion is wrong. You got to go in there and revise what you saw in the lab. Maybe you got to change your hypothesis. Maybe you got to make a new set of assumptions. You never thought of that? No, they just kept rolling with the particles, and they said, oh, the particle bounced back. Well, how do you know it was a particle? Maybe it was, like I said, maybe it's not a bullet that you shot and got back, ricocheted. No, maybe what it was a drill bit. You're with your drill, you're going zzz, and the other drill bit came back out and said zzz. So drill bit is not the same as shooting bullets. Okay, so if we make a new set of assumptions, we end up with different conclusions. That's the point I'm trying to make. Okay, so yeah, for those who hit up on this channel, well, you see a different universe because we're not talking about bullets, we're talking about drill bits twirling in place. Okay, so it's a different model altogether. Okay, and so continuing with Mr. Rutherford, he said, okay, this is what the atom looks like. Okay, that was his conclusion. He says just a little ball, the electron rolling around the nucleus, in this case the proton. This is the simplest of atoms, the hydrogen atom, right? Okay, but what happened next was that Bohr and Werner Heisenberg, Werner Heise, they came up and they said, look, you cannot even imagine the atom, so don't even try. Whatever you come up with, it's wrong. That was their conclusion after at least 10 years of studying after Rutherford came up with his planetary atom, which Bohr contributed to, by the way, okay, because they were working together. And they concluded that, the atom was first this little electron rolling around the nucleus. They finally gave up on that, at least Bohr did. And he said, look, and Heisenberg, look, you cannot even imagine what we're dealing with here because it's nothing like you'll see in the real world. And so what does Al-Khalili do? Well, he parrots the party line. This is what he learned by rote in college. Okay, he said the Copenhagen interpretation proposed that the world of the atom ran on principles which were completely different to any that mankind had ever seen before. Okay, I'm not saying that that's not true. Yeah, okay, so it's different. What does that mean? And he said it means that the atom, the basic building block of everything in the universe, was unique and perhaps outside human comprehension. So they were already, putting the fine print, saying, hey, it's beyond human comprehension. Don't try to imagine it because whatever you come up with, it's wrong. And today we have the same answer. You go to the university and they say, well, that atom that you learned in high school, the little planetary atom, that's okay for babies, kindergartners, that's there. When you come here, we've got a better atom. It's the one you can't imagine. That's what you get. That's what you get in college. So if you want to miss 10, you don't want to lose 10 years going to college, I'll tell you right up front. The one you learn in college is that you cannot imagine it. Okay, so let's get that straight right up front. They'll all tell you that. Okay, so here we have the atom that you're not supposed to imagine, which are nucleus made of these little balls there, supposedly protons and neutrons, and you have the little whatevers, little beads just floating around and buzzing around like bees on a beehive. Okay. And yeah, so we have a problem here because this is my version of their atom. If their atom is a proton and an electron, what prevents them from illustrating that proton and an electron? Here you have it. That's the hydrogen atom. What's so difficult about this? I mean, that's what they show on the chart, on the standard model chart. They don't show the proton these days. They show it as 3 quarks. Fine, you can put 3 quarks inside that proton if you want. And then you have the electron next to it. That's a snapshot of the atom when it's not moving. Okay? When it's standing still. It's the only object in the universe, even though there's 2 objects there, the electron and the proton. If that's their atom, there it is. What's so difficult about it? Why can't you imagine this pair here? And yeah, the reason you can't imagine, the reason that's not true, that's not the actual atom, is that an atom behaves in such a way that denies that that's the atom. They use that atom anyways. They use the planetary atom to explain ionization. They use it to explain electricity. The little bead going from atom to atom. They have no problem there. They invoke that planetary atom. When you say, well, is that the atom really? Well, no, it ain't. Well, if it ain't, then why did you use that as a model? If it ain't, show me the real model. And of course, they can't put the real model. They use that model always to explain electricity, and then they deny that that's what it is. They say, well, that's just an analogy. Don't take it seriously. And you say, well, but you just explain how the electron moves from atom to atom. So I guess what you're saying is that its electron is a little bead going from bowling ball to bowling ball. That's your explanation for electricity. Ionization along the same lines, the electron just leaves the atom, right? Or another electron comes in case of negative ions. That's what you just explained. So you're saying that's your atom? How can you later on deny and say, well, that's not my atom? Then your whole presentation was garbage. That's what you're telling me. Because that's the atom you use to explain electricity. Are we understanding ourselves or not? We got a problem because they point to this atom, to this atom, right? The bgaede model of the quantum hydrogen atom. And then they say, yeah, that's what we're going to use to explain electricity, but then don't take it seriously because that's not our atom. Okay, so we got a problem. We got a problem because these people cannot explain any phenomenon in the invisible world of the small. And then they claim they proved it, that computers wouldn't work if quantum were incorrect. So what are they talking about? We got a problem because they can't imagine their atom, but they say they proved it. They say they cannot explain, but they know exactly what their atom looks like. It looks like a planetary atom. We got a problem, folks. Forget it. No matter how you twist and turn this, we got a problem. Okay, so here's Man Al-Khalili. He says, as scientists explored the nucleus, they found it bursting with powerful energy. Yeah, they started to what they claim is split the atom. I'm saying they split their heads. They never split the atom. There's another mechanism to explain, atomic behavior or fission. Okay, but they thought they split the atom, that they parted the atom in half. Like parting your heart in half or something. Okay, this discovery gave them a fundamental understanding of how the universe itself was created. My God, they took this a step further, and now they can tell you through the atom, okay, they can tell you how the universe came into being, meaning how matter came into being, okay? Because here you have this burst of energy coming out of such a small thing. Once you parted the seas right there, so to speak, you parted the atom. Okay, you have all this energy. Now we know how the universe came to be. There was a big explosion. All this energy was released, and that energy, a concept, right, turned into matter. Because Einstein already showed that energy is equal to mass times velocity of light squared. And what is mass? Matter. In the jargon of mathematical physics. So you got to replace that word mass with the word matter, and you'll be okay. You'll understand perfectly. In other words, energy turned into length, width, and height. It acquired length, width, and height and turned into matter known as mass, known as weight. Okay, that's essentially, the theory. Okay, so what are the problems? And the problem comes from Al-Khalili himself. He said, I'm not saying this, that's him saying this, okay? By the late 1920s, the equations of quantum mechanics were consistently getting the wrong answers when describing electrons, okay? We're talking about 1929, etc., okay? What is it, the roaring 20s, okay? Just before the stock market crash. The constituents of atoms as they moved at very high speed. So now they could not explain the behavior of electrons moving at high speeds. What were they trying to analyze here? They were trying to analyze special relativity. Okay, because they were trying to incorporate special relativity, the conclusions of special relativity. In other words, moving at the speed of light or close to the speed of light, what would happen to objects? You get length contraction, mass increase, you got all this nonsense out there. And they said, well, how do we incorporate this into quantum? Because now here we're shooting electrons at very high speeds. And so how do we explain the behavior? It doesn't match. They couldn't merge the equations of quantum mechanics with those of special relativity, especially, or you could even say general relativity, or relativity in general, okay? Okay, so where do we go from here? Okay, and well, what happened was instead of fixing the problem, they just made it worse. They brought in good old Paul Dirac, and what he came up with is his equation, the Dirac equation, having to do a little bit with the Dirac sea of all these particles floating out there, making up space, coming in from the void. You have matter and antimatter joining hands and turning into space, and then splitting apart and forming very brief particles that come into our world just to make the mathematical equations come out right. You know what I mean? Okay. As well as matter, Dirac's equation predicts the existence of antimatter. Okay, that's what that equation does. Okay, for every particle there can exist an antiparticle. Okay, this opened a can of worms because the first problem was that it was confirmed, as you know, all these things are usually confirmed through experiment. And so what was the issue? The issue is that good old Dirac predicted one thing, that, and this is very important, okay, that if you get matter and antimatter together, there's a big kaboom, big explosion, big no, you don't want to do that ever, okay? And he said, he says, and there's one final prediction of the Dirac equation. It, as its punchline, it states that matter and antimatter must never come into contact. Because if they do, they will annihilate each other in a fierce conflagration of pure energy. Okay, whatever that is, okay? Energy, a concept, so they end up being a concept. The combined mass of matter and antimatter would convert completely into energy, to a concept, according to Einstein's famous equation, blah, 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 okay? If I ever do meet my doppelganger, we would explode with an energy equivalent to 1,000,000 Hiroshima-sized atom bombs. Okay, you understood that, okay? You got matter and antimatter. If they come together, you get nuclear explosions, nuclear level explosions. We got that straight? Okay, let's find out what the problem with that is. Okay, here goes, okay? Now go get your beer, because you're going to need a beer for this to understand this. Here it is, okay? According to good old Al-Khalili, says antimatter, particularly antimatter electrons called positrons, are made routinely now in laboratories. They make them in labs every day. The CERN Fermi lab, SLAC stands for linear accelerator. They make antiparticles every second. That's what all these people do. They just shoot whatever this invisible stuff. They create antimatter, and then the antimatter immediately recombines with its matter. And as far as I know, we don't see all these explosions all around us. He just said that if matter meets antimatter, we get this big boom, this kaboom. And he says we make it every day in the labs. Oh, I hope you make sense of it, because I can't. Positrons are used in sophisticated medical imaging devices called PET scanners that can see through our skulls and accurately map pictures of our brains. They're throwing these positrons, these antimatter particles, into your brain. Maybe that's what's causing your dementia. Yeah, we got a problem with all these bozos because they're contradicting themselves. On the one hand, they tell you, look, if matter and antimatter come together, big kaboom, nuclear explosion. And then they say, oh, it's happening all around us. All these antiparticles and particles are coming in from the void and then recombining it, releasing a whole bunch of energy. So we got all this energy just exploding in front of our eyes. I wonder why we don't notice it, because if it's like nuclear explosions, you would think that you would at least notice it, maybe even hear it, you know. Absolute nonsense. Well, okay, a few years later, this fellow here, Carl Anderson, supposedly he discovered what I call the sup-positron. He supposed that that line that you see, that curved line, the big one right there almost in the center, he said, look, that's an antiparticle, because, or antimatter, because it's moving in the wrong direction. It's moving positively when the electron, if it were an electron, it would be moving in the other direction. It would be moving positively. So he supposedly discovered the positron. And for this suppositron, the discovery, he got the Nobel Prize in 1936. So this is not trivial matter, okay? Now, in science, Mother Nature, she doesn't know what positive or negative or North Pole or South Pole are. All she knows is what clockwise and counterclockwise are, okay? So if this is a counterclockwise, and the electron would do a clockwise, all we have is something that these people don't understand, which is that curve there is only a counterclockwise curve. That's all it is. No positive, negative, no North Pole or South Pole. It's just clockwise and counterclockwise. Period. We're done. That's physics. That's not math. What this guy did was math. Okay, again, these guys were not bright, not one of them. They should all return their Nobel Prizes because they're worthless anyways. They're just pieces of tin that they give out. Okay, of course you can buy a lot of beer with the prize, but these people just give prizes to each other. That's all they're doing. Then the guy who receives a prize then becomes he's one of the guys who can designate who the next Nobel is. So it's a self-perpetuating system. That's why quantum is still around today, because all these guys just give pats in the back to those people who follow them right after them, from the next generation. So it's a self-serving, self-perpetuating system that we've created. We humans, smart humans, right? All we did was continue to paint ourselves into a wall. Okay, so here you have the Dirac equation, and it says describe one electron. It failed to explain behavior when there was more than one electron present. That was the shortcoming of Dirac's equation. How do you deal with electron to electron interaction? And wouldn't you know it, they always have a solution. And the solution came from a fellow by the name of Richard Feynman. What was it? I think 1948. And he invented this nonsense, the so-called quantum electrodynamics, okay? And he came up with these so-called Feynman diagrams. And you see that little squiggly line. And what are we seeing there? Well, you see a positive electron and a negative electron. And they shoot out this little thing. That's how this little squiggly line, whatever that is, I guess it's a wave, you could say, or maybe it's a particle going up and down. I don't know how you're supposed to interpret that picture. The funny part is that Niels Bohr, who heard his presentation, and Paul Dirac and all these other fellows from the old days, Heisenberg, they called him an idiot. Yeah, they called Richard Feynman an idiot. That's what Al-Khalili says. They called him an idiot because he was trying to make a picture of what was happening, and they said, you're crazy. You cannot even imagine what's happening out there in this invisible world of atoms. And this guy was drawing it. Now, how was that for overthrowing the old regime, okay, the old guard? So they were absolutely pissed at him. But what happens is the old guard died, and the new guys, like Schwinger and him, who got the Nobel Prize for this nonsense, they took over, and they overthrew the old people, okay? And they started making pictures of the atom back again, okay? One of the guys who participated in that was, well, hold it, here's one step here in between. Al-Khalili is shocked because Feynman says that he cannot even imagine his own theory. Says, so what does QED actually say? It may be a wonderful scientific description of nature, but trying to understand what Richard Feynman was doing with his theory is almost impossible. No, not almost. It is impossible. This is what he himself said when he introduced his theory to the public. It is my task to convince you, not to turn away because you don't understand it. Okay? You see, my physics students don't understand it. That's because I don't understand it. Nobody does. So Al-Khalili makes this comment. He says, if the inventor of the theory doesn't understand, what possible hope is there for the rest of us? Yeah. What possible hope is there if no one understands, as Feynman says, and certainly Bohr and Heisenberg and Dirac, who were at the meeting, they said, we don't understand it. And he said, yeah, you're not supposed to understand it. You're just supposed to visualize it the way I'm putting it here in little pictures on the board. And so they were upset. They said, you're trying to draw the atom. You're trying to draw the behavior of the atom. You're trying to illustrate electron to positron interaction. And he said, yeah, but see, it's just a kindergarten thing just to visualize. No. Don't try to cheat. You can't cheat. You can't visualize it. Do you understand? You're an idiot. And so the idiots took over, and they overthrew the old guard. And Um, Here we have, if I can get this thing up here. So many of these. So what does Al-Khalili say? Well, he says even though no one can understand it, he's going to try anyways. Okay, you're supposed to try to listen, follow his steps. Okay, he can visualize it for you, so please try to understand. But he starts out on the wrong foot. Okay, he says with that disclaimer, I'm going to try to explain anyways. Okay, first you have to abandon your most basic intuition about nature. Oh man, that's a bad way to start a presentation where you're trying to explain to someone who you want to understand your theory. He said you're supposed to abandon your intuition. Leave all rationality behind. Okay, I'll do that. You have to give up the notion that empty space is empty. Okay, so that's how he starts. And then he says, quantum electron dynamics says that the vacuum is not the place where nothing exists and nothing happens. Instead, it's full of stuff and it's heaving with activity. And there you have it. That's the quantum vacuum. Just a bunch of particles made of, again, what is it? What did Paul Dirac say? Matter and antimatter that just keep recombining, known as annihilation, and then coming back into our world whenever the mathematician needs to explain something. So he brings these particles in momentarily because I don't understand what the purpose of these particles is. If the particles just come in and then immediately, because he says they last a very, very short time, picosecond or even less, in our world then go back, then what's the purpose of these virtual particles? Well, no, that's the explanation he gives you, but then the mathematicians bring them in and they do a lot of stuff with these virtual particles for hours and hours. So the virtual particles running around, they explain a lot of stuff with that. And say, okay, now we're done with a virtual particle. You can go back, be in space again. Go recombine. And do your boom and do that nuclear explosion. Just don't blow me away. We got a problem with the mechanisms. Of course no one understands this because they don't make it understandable. Okay? Okay, but if you thought that irrationality stopped there, no, then we have this fellow. His name is Murray Gell-Mann. And he came up with a 3-quark deal. He got a Nobel for this nonsense, saying that, yeah, we have these 3 quarks. They make up protons and they also make up neutrons. And of course, they fit in the gluon in there to keep track of the standard model, which was becoming what they called a particle zoo. Everybody was getting a Nobel Prize for discovering a new particle every day. And so that's why we ended up with so many particles. The main ones are like 12. There's a couple more, like the graviton is not part of the standard model. But they have a total of like 200 particles. You have phonons, the particles of sound. You have tachyons, particles go faster than light. You have, what is it? What's the other one, famous one? The chronons, particles of time. And then you have the particles of mass, of weight. You have the Higgs. So they have all these particles, out there. They got like 200 particles sub-particles that they created, muons, pions, the whole works. You got a bunch of particles out there. And so the question is, what does this lead to? Well, first let's summarize what Al-Khalili said essentially. Okay, here it is. Give me a second here, okay? The mechanics started out by claiming they proved the existence of the atom. That was at the early 20th century. From there, they figured out that the atom was mostly empty space. Then they figured out that empty space is not empty. They have all these matter and antimatter particles out there that make up space. Like I say, a black ball and a white ball, they get together and form a no ball. Yes, they have no balls in quantum, okay? And quantum empty space. Empty space is full of these particles doing a lot of activity out there, so they are particles, okay? Dirac invents antimatter, that's part of that deal. Anderson confirms it, okay? If matter and antimatter collide, you have a nuclear explosion. However, the mechanics claim they produce antimatter every day in the lab, okay? So we have a problem there. Okay, and Feynman invents QED with his little kindergartenish diagrams that offended all the old guard. Okay, he did it to solve Dirac's inability to deal with 2 electron interactions. Okay, and then Gell-Mann invents 3-quark to make protons and neutrons. So that's the model. That's the vision you're supposed to have of the atom today, of the quantum atom, whatever that means to you, whatever vision you have of that, because once you get that vision, they say forget it. You're not supposed to imagine it anyways. You can't imagine it. Okay, it's just used for visualization. So you ask, well, what's the state of the art physics today? Where has all this taken us? Okay, what's the conclusion? What's the corollary to all this? And yeah, here it goes. Again, get a beer. You're going to need it. Okay, here it is. Bohr and his generation overthrew the old order of classical mechanics. Okay, the people who died at the end of the 19th century, including Einstein, those people, they were left behind. They said, you guys don't know anything. We've got a new model, and it's this quantum model, which Einstein at least didn't believe in. A lot of the old folks didn't. I know this Michelson from Michelson and Morley experiment. He didn't believe in the quantum model. Even, what was the name? Max Planck. He didn't believe in this quantum nonsense. Okay, he tolerated it and saying, well, this is a new generation, but he didn't believe in it. De Broglie and Schrodinger, they overthrew Bohr's little particles, quantum jump and so on. They said, no, it's a wave and it's cloud. And then Dirac comes in there and Anderson confirms it. And they said, no, look, forget about your waves. It's particles, because we have all these particles and antiparticles, matter and antimatter out there, and they form not only the background, the empty space, but they also form the atoms. Okay, and that was confirmed later on by putting the quarks that Gell-Mann came up with. Feynman overthrew Heisenberg's notion that the atom cannot be visualized. And what happened in the end? Well, string theory overthrew them all, because nobody does quantum mechanics anymore today. It's all string theory. That's where we're moving into. Every student of so-called physics, mathematical physics, they're abandoning quantum mechanics, because quantum mechanics has no solution to quantum gravity. And so quantum gravity is a buzzword for string theory. And they're going into this math. They're not going into physics. They're not trying to visualize any of this. They're going into string theory, which is math. They're trying to get an equation that unites quantum with gravity, quantum with relativity. And of course, they have a big problem there, because again, relativity is warp space and quantum is force. And we got a problem there, because two different mechanisms. How they're going to get the equations together, well, only God knows. Corollary, we have no use for accelerators, because if quantum is dead, essentially, right, other than for dark matter, which they're trying to, that's the new jobs of the people working at the accelerators. They're into dark matter, okay, and dark energy, because forget about the atom. That's already complete. They can't do anything more with that. That's where the string theory is to worry about. The vibrating line. Okay, and meanwhile, these guys say, what do we do? Well, why don't you guys work on accelerating stuff in there and try to produce dark matter? Okay, which is what we need to figure out, how what's happening out there in the galaxies. Okay, so the issue is that essentially they have no use for these white elephants like CERN and SLAC and Fermilab. No use for them anymore. It's like, just look busy. That's it. So if you work there, just look busy. You got a high level job. You get paid. You were recommended by your advisor, physics advisor or PhD advisor. You're done. You got a career. Forget about trying to make sense of any of it. And these are the people who are followed by millions of people who say, oh, these guys know, because otherwise we wouldn't have computers and GPS and so on and so forth. That's the state of humanity today. Okay, that's where we arrived. With that, I'll see you, on Wednesday. And I hope you don't annihilate yourself by finding your alter ego, your nemesis out there. We'll see you then. Bye.